Alright, in this video we're going to look at distancing stars and distancing things in the universe and the galaxies, and just getting an idea of what distances there are. So we're going to be looking at, hopefully over the next couple of videos, looking at a number of different values. So the first value I want to make you aware of is the astronomical unit. Now the fun thing about this one is it's a real fudge, because we needed a distance that we understood and we have a concept of. So we thought, well, why not start measuring things in terms of our distance to the sun? So if you imagine our solar system here, our solar system, here is our sun in the middle, and this is us orbiting around it, Earth. So we thought, well, what a useful thing would it be to actually judge things based on, as good scientific practice, judge things based on how far they are away as a proportion of the distance from us to the sun. So for example, here, what we call this distance here is 1 astronomical unit. It just made it really easy to effectively turn around and say, okay, we're going to measure everything in AU, and 1 AU is the distance from us to the sun. So we know that if something is 2 AU away from us, we know it's 2 times the distance from the sun. And so on and so forth, up to any number of AU that you want, which is a useful unit to use for a number of different circumstances, especially when it comes to astronomical distances. Now, obviously, we need other units as well. So we have the Lightyear. Now, most of you will have heard of the Lightyear before, but may not have had a concept of what it is. So a light year, 1 light year, is effectively a distance. So be careful, because a lot of people think a light year is a time, so because you've got this word year in there, so you think of time, but it is got a time aspect into it. It's the distance traveled by light in 1 year. And actually you can work that out, and one of the things I'm going to ask you to do in lesson is I'm going to say, okay, tell me how many meters is a light year, and you need to work that out. I'm going to give you an idea about that now. So if it's the distance traveled by light in 1 year, we can work out what this is in meters. Well, we know that light travels at a velocity of 3 times 10 to the 8 in a vacuum. And that in a year, the time is, well, there's 365 days in a year, times by 24 hours in each day, and each hour is 3,600 seconds. And so as a result, you can work out the number of seconds in a year. Guess what? If you've got a velocity and a time, velocity equals distance over time, you can work out what the distance is by velocity times by time, which you've just worked out there. And I'm not going to do that for the sake of this video. It's just to show you that what a light year is in terms of an astronomical distance. So as you can imagine, light travels pretty fast, so in a year it can travel a long way. So yeah, this is the next biggest unit. So we're starting to wrap up, we're starting to see the sizes that the universe can take. But we can go to another unit that's useful as well. Now, in order to explain this unit, we need to actually introduce your thumb. This is a great method here. So your thumb is a great indicator for showing how parallax works, or how the parallax method of distancing stars works. So if you hold your thumb up to in front of your face, and effectively your thumb represents a star that you may be looking at. Now if you close your left eye and look at that, and just perceive it with the background behind it. Look at a picture on the wall, place it next to the picture, place your thumb so it's next to something on the wall far away from you. And then what you can do is you can then close your other eye and open your other one. Notice that your thumb moves with respect to the background. So it moves, it appears to move. Even though you kept your thumb still, the background changes based on your perspective that each eye is looking at. So we use that method to distance stars, and we'll show you how to do that. So say, for example, here's us, here's the sun, sorry, and this is us on Earth orbiting round in this orientation here. And we're looking at a star all the way over here. At this point in the Earth's rotation around the sun, we observe this star against a backdrop of stars. So these are all stars. And we see it with respect to the stars that have not moved at all. And then if we look at it again 6 months later, we then see something slightly different. The star looks the same, but its position amongst the stars in its background has changed because we're looking at it from a different angle. This is parallax. You see the same thing if you have a clock or anything like that. If you stand to the far left of the clock and look up the clock, try and read the time, then you start on the far right of the clock, read the clock, it will appear to be a different time, even though it's just because your perspective of how you're looking at it. So in this circumstance, we're looking at it there, and we're looking at it 6 months later. And that 6 months later, we can then use to measure a angle. And the angle is the angle that's right here. Okay? And that angle is otherwise known as a parallax angle. Now bear in mind, we know this distance is 1 AU. So what we can actually do with this is we can assume another unit. We can make up another unit that makes our lives really, really, really easy. But in order to do that, obviously, as you can imagine, these stars are really far away. So these angles are going to be absolutely tiny. So we need to know how we measure tiny, tiny angles. Well, how do you normally measure an angle? You use a protractor. And on a protractor, a section on the protractor is split up into 90 or 180 degrees. Or if you've got a really fancy one, 360. But for all intents and purposes, you've got degrees that are set up. And you could say that you have 90 degrees in this angle here. But what's smaller than a degree? Well, I guess you could say what's half a degree. Well, yeah, but what about like a smaller version of that? So what we did is we introduced a new version of that. So imagine 1 degree on here, okay? Between those 2 degrees, so this might be 1 degree and 2 degrees, and obviously we want to measure a much smaller angle than that. So what we can actually do is we can actually split up 1 degree into arc minutes. And there are 60 arc minutes in 1 degree. So there are 60 arc minutes in 1 degree. Which quite nicely also means that an arc minute is 1/60th of a degree. So that's what an arc minute is. So an arc minute is a 60th of a degree. But what if we want to go smaller than that? Because again, these stars are really, really far away. So we want to measure smaller than an arc minute. Well, we can split an arc minute up into, hopefully you guessed it, arc seconds. And there are 60 arc seconds in an arc minute. which helpfully we can then turn around and say, okay, well if there's 60 arc seconds in an arc minute, that means that 1 arc second is 1/60th of an arc minute. And 1/3600th of an degree. Or a degree. So 1 degree. So an arc second is 1/3600th of an arc there is a 1/3600th of a degree is an arc second. So now we have a really, really small angle that we can use. And so we do. We use really, really small angles. And we say that a parallax angle of 1 arc second, will subtend, the distance here will be what we call a parsec. So where the parallax angle is 1 arc second, we have a distance to that star from our sun of 1 parsec, and that is now a new unit. So we have another unit. So we've introduced the astronomical unit, which is based on the distance from us to the sun. We have the light year, which is based on the distance that light travels in a year. And we have now the parsec, which when we use the parallax method, if we have an arc second as our parallax angle, that means that object is 1 parsec away. And we can use this as a nice handy little method to help us out. So is there an equation for this one to help you out? Well, yes, there is. So you'll notice that 1 arc second gives you a distance of 1 parsec. So 1 parsec. So we can say that the distance in parsecs is equal to 1 over the parallax angle in arc seconds. Interestingly enough, you might notice where this 1 has come from. This 1 has come from 1 AU. And this equation is actually derived out of trigonometry. Those of you who are savvy will notice that this is a right-angled triangle. So this equation comes out of trigonometry and small angle approximations for trigonometric functions. So we don't need to worry too much about that at this stage. As long as you're happy that a distance in parsecs can be obtained when we know the parallax angle of a star based on our observation of it, 1 divided by that will give you the distance in parsecs, which is a really, really nice method. Now, what are the limitations of this method? Well, there are loads, okay? Because obviously, there's only so small an angle that we can get. So actually, the distance is limited. And really, for all intents and purposes, when we start talking about distant stars into the galaxies, this method is pretty much useless because galaxies are so far away. We start talking about megaparsecs, which mega is times 10 to the 6, and as you can imagine, that is a long way away. So these measurements and calculations don't work too well for those. And there are other methods that we can use to distance stars. So this was the first one, and introducing all the units that we're using, parsecs, light years, astronomical units, and we're going to start looking at other methods of distancing stars in the next few videos.